Okay, let's begin in the first question. It says a 25 kilogram box sitting on the desk. Draw a nice little square. First thing you can always put in is gravity because it's always there. (245 newtons). And the box is not moving up or down, it's just sitting there, so everything is balanced. There'd be a normal force, which will also be 245 newtons. Yeah, that one's good. Next one, it's a 16 kilogram box. How much force does it take to get it to move? Here's 16 kilograms. You can always put gravity down because it never changes. 156.8. And it's not going up and down, so the up has to balance it. And that's your normal force, which would be 156.8 newtons also. And that's the one that friction's based on. So if we're going to do to get it to move, it's sitting still, so that's mu s. Which would be 0.6 times 156.8. That's 94 newtons. That's to get it to move. Okay, to keep it moving, it's going to be moving, so we're going to use kinetic. So we're going to find the friction. It'll be mu k times the normal force, which would be 3.4 times 156. So we go 0.4 times, we got 62.7. And that's just to keep it moving. Okay. Next question, it says, examine the following set of blocks. There's 56 newtons of force pulling on the whole thing. So I could look at that as a big picture of 14 kilograms being pulled with 56 newtons of force. There's no friction in this question at all, so we can just say F equals ma. The force is 56 newtons, the mass is 14, and A is your unknown. A equals 56 divided by 14. I get 4 meters per second squared. That's the acceleration. And if I want to find the tension, let's call this T1, call that one T2. Tension 1 is only pulling the 4 kilogram block. So we can look at that one here. If I put a 4 in there, and I know it's accelerating at 4 meters per second squared, that needs the force needs to be ma, which will be 4 times 4. 16 newtons. Now if you want to look at the tension 2, it's essentially pulling 10 kilograms of stuff at 4 meters per second squared. So F equals ma again. That's 10 times 4 equals 40 newtons, and that will be the tension on there. Okay, you could double check things. If I had 40 here and 16 there, 40 minus 16 is 24. 24 net force on 6 gives me an acceleration of 4 meters per second squared. So you can do the tug of war in the middle there, but it's much easier to clump it together as a block. Okay, so those are the first page. Next page. This one's broken down into pieces for you. So first thing, they get a force on an angle. I say break it into the components. So x is cos, so that would be 60 cos 30. And y is sine, so that'll be 60 sine 30. So 30 cos times 60 is 51.96. I'm pretty sure sine 30 is a half. Yep, times 60. It's 30 newtons. Okay, determine the force of gravity. Well, that's always constant. 6 times 9.8 is 58.8. Okay, find the normal force to balance the other two forces. So it's probably a good idea to draw this one out. Maybe I'll do it over here where it's a little more room. I have 51.96 newtons forward, 30 newtons up based on that one. Gravity's down at 58.8 newtons. this thing is not going up and down, so there needs to be a normal force here such that these two add up to that one. Okay, so that's what we're looking for, the normal force. So some normal force plus the 30, because somebody's pulling up on this, helping to fight gravity, equals gravity. And then you can just solve for Fn. It'll be 28.8 newtons. Okay, and then they said, find the force of friction equals mu k times the normal force, which we had to find out first. That's not net force, that's normal force. Okay, it's already on my calculator screen, so 5.76. And they said, draw the free body diagram, all the forces on it. So I have to redraw this box. I have 51.96 newtons forward, 58.8 newtons in the down direction. I have 30 newtons up from the rope, and I have another normal force of 28.8. And finally we got friction, the last one here. Force of friction is 5.76 newtons. And then you're all done.